Hey guys, so today's video is going to focus a little bit about what the unit circle is and how we can use the unit circle to answer any kind of trig questions that might pop up in the HSC. So our unit circle looks like this. It's a circle with all measurements of 1, so our radius of our circle is going to be 1. And then we have it split up into 4 different quadrants. So we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4, all going anti-clockwise from the start there. So this angle here would be 0 degrees, then we go up to 90, 180, and then 270 degrees, all the way back to 360, back where we started. So within our unit circle, what we can actually do is draw in some right angle triangles within each of the different quadrants. So our triangles are going to look like this. And if we label the first acute angle within our right angle triangle as theta, that's going to be whatever's going to be in our first quadrant. So first quadrant here, all my sine, cos, and tan ratios are all going to be positive because my x and my y axes here in this quadrant are positive. So any trig ratio that I get is going to be a positive number. If I then move over to the second quadrant, say I wanted to find whatever this angle is in here, this is theta now, I'd have to go, okay, well, my angle of my straight line is 180. So therefore, to find my yellow theta there would be 180 minus theta. Now, within quadrant 2, only sine is going to be positive. So we can remember this acronym, or stations to central, to remember which corresponding trig ratio is going to be positive in the respective quadrant. So if we move down the line, looking at the third quadrant, if this was my theta, I would then have to go all the way again, starting from the first. And that's going to be my angle of my straight line again, so 180 plus theta now. Now this means that only tan is positive in your third quadrant. Moving on to the last quadrant, so that we labeled as central, only cos is going to be positive here. So if we want to find out how we can find any acute angle in the fourth quadrant, we'd have to go all the way around. Here's my theta. So therefore we know the full revolution of a circle or any revolutionary angle is going to be 360 degrees. So we can go 360 minus theta in order to find out what theta is going to be in there. Okay, so that's the main things to remember. So this acronym here, or stations to central, helps us to figure out which a corresponding trig ratio is going to be positive. And then what we can do is use these respective expressions to see how we can answer different types of trig questions. So if we have a look here at a question from the 2023 HSC, question 20, we have find all the values of theta where it has a respective domain between 0 and 360, such that sine theta minus 60 is equal to negative root 3 on 2. So with this kind of question, the first thing I can see is that it's negative. So if I have a look back at my unit circle, I know that sine is going to be negative in my third quadrant and my fourth quadrant, because in my third quadrant only tan is positive, and in my fourth quadrant only cos is positive there. So therefore I know straight away I'm going to be working with my two formulas that were given to me in quadrant 3 and in quadrant 4. So quadrant 3, we said that my expression was 180 plus theta. And in quadrant 4, we said that my expression was 360 minus theta. So to find what theta actually is, we just find the inverse of whatever the ratio that they've already given to us. So since we have here that sine theta minus 60 degrees is equal to negative root 3 on 2, our theta is going to equal to whatever sine inverse of root 3 on 2 is, which we know is going to be 60 degrees. That being said, we're not really interested in the first quadrant because this would be your acute angle in your first quadrant. We're interested only in the value of it in quadrant 3 and quadrant 4. So what we can do is we can go theta minus 60, because that's what's in my brackets here, is going to equal to 180 plus 60, which is going to give me 240, and 360 minus 60, which is going to give me 300. Okay, once I've written that down, because I'm working not with theta now, so in my unit circle, I was working with theta. Here I'm working with theta minus 60 because that's what it's given to me in the brackets. So I want to make sure that I reflect this in my domain as well, because I'm not solving for theta anymore. At the moment, I've made theta minus 60 the subject. So we need to work out our new domain so that we include all the values, because this question wants us to find all the values. So therefore, theta minus 60, to find my new domain, I just have to minus 60 degrees from both aspects of my domain. So 360 minus 60 is going to give me 300, and 0 minus 60 is going to give me negative 60. So therefore, I need to find all the values that's going to be between negative 60 and 300. So at the moment, I only have 240 and I have 300. I can go all the way now to negative 60, so I don't have to stop at 0. So I can find my correlating angle here. So if I minus 360, so I'm doing one full lap of my unit circle. So let's say 300 is about here. To find another lap around, I can go 300 minus 360, which is going to give me negative 60, which is in my domain. So therefore, my values for theta minus 60 are negative 60, 240, and 300. So now that I've solved for theta minus 60, I know that I'm actually trying to solve for theta here. So therefore, what I need to do to all my solutions is add 60. So therefore, theta is going to equal to 0 degrees, 300 degrees, and 360 degrees. So if we didn't change our domain at the start, if we didn't work with the unit circle there, we wouldn't have been able to find all the values because we wouldn't have got that negative 60 there. Okay, so hopefully that helps you understand the unit circle a little bit better. These questions do try to catch you out a little bit, so make sure that you are changing your domain and using the unit circle to figure out the exact values as well.